Now, let me show you more example. First, we need to plot a graph of the function y equals to x squared minus 4x plus 3 between the range of x, -2 and 5. Then, we need to use the plotted graph to solve each of the following quadratic functions. In order to plot the function, first, we need to construct a table of value. The table consists of the following columns, which are x as an input. Since input is limited between -2 and 5, so we only have to consider the value of x between -2 and 5. Then x squared for the next column, -4x plus 3, and y. Lastly, we need to write the coordinates x and y. The table of value is as this, where we have the input between -2 and 5. Then we need to evaluate all of these columns according to the input. So, when the input is -2, it has been evaluated, and thus we know that the coordinate is equals to x and y. So this is how we plot it. Then we have to evaluate all these cells and find the coordinates which is corresponding to each input of x. By using this spreadsheet, it is convenient for us to compute. So now we have plotted all the points. Now it's time for us to join all the lines here with a smooth curve, which can be used to represent the function y equals to x squared minus 4x plus 3. So this is the line. Make it bigger so that it's clearer to you. That represents y equals to x squared minus 4x plus 3. So all students, as you can see, it is a very smooth curve. Now, we can use this to solve the quadratic functions given in part B. First, in the first quadratic equation, x squared minus 4x plus 3 is equal to 2. It also means that we need another line to solve the equation, as we have learned in the previous video. The line is y equals to -2. Oops, it's y equals to 2. So the intersection between x squared minus 4x plus 3 and y equals to 2 will be the solution for this quadratic equation. Now, this blue line represents y equals to 2, and we can see that the two lines here intersect one another at 2 points, which is at point A, where the x value is 0.27, and point B, where the x value is 3.73. So, we know that the solution is x equals to 0.27 or x equals to 3.73 for part 1. Then, for part 2, we need to solve the quadratic equation x squared minus 4x plus 3 equals to 0. So again, we need another line, which is it is y equals to 0. What is y equals to 0? Well, it is actually the x-axis. So now, the purple line here represents y equals to 0, and we can see that they intersect one another at the point f5 and f7. So what is f5? It is 1, 0. f7 is 3 and 0. So the solution for the second quadratic equation are x equals to 1 or x equals to 3. Then x squared minus 4x plus 3 equals to negative 2. So the second line that we have to draw is y equals to negative 2, where it is below the curve. Y equals to negative 2. As we can see here, the red curve and the green line doesn't intersect one another. So it means that there is no solution. Then another quadratic equation, x squared minus 4x plus 3 equals to 2 over 3x plus 4. Now, we have this as our straight line. Y equals to 2 over 3x plus 4. As we can see, this is actually y equals to mx plus c. So, we can use the method that we learned in the previous chapters to draw this line. And it is a line as is. As we can see here again, the purple line represents y equals to 2 over 3x plus 4 intersect the curve at 2 points, which is point E, where the x is negative 0.21, and point F, where the value of x is 4.87. So the solution for this equation is x equals to negative 0.21 or x equals to 4.87. X squared minus 4x plus 3 equals to negative x plus 6. Again, we need to plot the line y equals to negative x plus 6 and find the intersection between them. So, the line is represented by this green line, and they intersect one another at point G, where the value of x is negative 0.79, and point H, where the value of H is 3.5. 0.79. So for part 5, the solutions are x equals to negative 0.79 or x equals to 3.79.